बर्तमान देखा rules for using symbols of the SI units. So, full names of unit, even if they are named after scientists, should not be written with the initial capital letters. Example, Newton but not Newton. Symbols for a unit named after a scientist should have a capital letter. So, example, N for Newton, W for watt and A for ampere. Punctuation marks should not be used after the symbols of unit. Example, 100 kg but not 100 k dot g. Symbols for units should not take plural form. 100 newtons is 100 newton but not 100 newtons. 50 meters is 50 m but not 50 meters, and so it is not written in the plural form. So, MCQ question, which of the following is the correct form of expressing SI unit? So, it is Newton. Which of the following is the correct rule for using the SI unit? Symbols for units should take plural form. Symbol for units should not take plural form. Punctuation marks should be used after the symbols of unit. A small letter is used when symbols of unit is expressed after the name of the scientist. So, the symbol of unit should not take plural form. So, this is the correct option. Now, I am talking about measurement of length. We are familiar with some direct methods for the measurement of length. A meter scale used for length from 10 to the power minus 3 meter to 10 to the power 2 meter. A screw gauge and a spirometer can be used to measure length as less than 10 to the power minus 5 meter. A vernier caliper is used to measure the length to an accuracy of 10 to the power minus 4 meter. So, this is the vernier caliper. So, measurement of a large distance. So, large distance, to measure large distance such as distance of planets or stars from the earth, that cannot be measured with a meter scale. So, an important method is used, that is called parallax method, to measure these distances. When an object located against specific point on a wall is viewed with only one eye, say first with left eye and next with right eye, then the position of that object seems to be changed with respect to point on the wall. This is called parallax. So, the distance between the 2 points of observation is called the basis. So, distance d of far away planet P measured by observing it from two different places on the earth A and B, separated by a distance the B, that is called basis. AB is the basis, and if it is sustain an angle theta between two directions of observations, that angle is called parallax angle or parallatic angle. Since theta is small, AB considered be as a arc of length B of circle with center at P. So, and distance D as radius. Here this is small, so it is a arc of and it is the radius. So, we know theta is equal to L by R. So, this will be B by D. So, in this case we can find the D. D is equal to B by theta. Two diametrically opposite points M and N of a planet are viewed through telescope from a point A on the earth by this parallax method. Let angle alpha between the two diametrically viewed measure. Suppose here this is a planet and this is the diameter of the planet, and here is the position on the earth. We focus the telescope on these 2 points from a single point, then we measure this angle theta. Then if diameter of this is D and distance already I measure D, then we can write D is equal to D into alpha, or alpha that is alpha is equal to D by D, or D is equal to D into alpha. So, बर्तमान देखा that is estimation of a very small distance, that is size of a molecule. So, very small size like size of molecule can be measured by special microscope called tunneling microscope. The size of the molecules can be estimated by a simple method experimented as below. To determine the molecular size of oleic acid, diluted solution of oleic acid in alcohol of concentration C is prepared. Lycopodium powder is spread on the surface of water taken in a tot. Now we keep a drop, n drops of prepared solution, each volume V are put in the water. The drops spread into a thin, large and roughly circular film of the molecular thickness on the water surface. So, the diameter of thin film is measured to get its area A. So, if T is the thickness of the film, but it is not nothing but the molecular size or molecular diameter, because it is a monomolecular layer, means single molecule layer on the water surface. Therefore, size of the molecule is equal to thickness of the film is equal to volume by area. So, total for if V is the volume of each drop, total volume is N into V. Here N is the number of drops we put in the water surface, and area that spread we measured already. Then we can find T is equal to NV by A. So, now from MCQ question, large distance such as distance of a planet or a star can be measured with the help of options: meter scale, vernier caliper, screw gauge, parallax method, that is parallax method. The size of a molecule can be measured by microscope, simple microscope, compound microscope and tunneling microscope, that is tunneling microscope. बर्तमान देखिए आम रेंज ऑफ लेंथ्स. The size of the object come across in the universe vary over a very wide range, that is from order of 10 to the power minus 14 meter to 10 to the power 26 meter. So, we also use certain specific length units for short and large length. So, these are Fermi. First Fermi, that is 1 Fermi is equal to 10 to the power minus 15 meter. Then 1 angstrom is equal to 10 to the power minus 10 meter. Then 1 astronomical unit, 1 AU. So, it is astronomical unit, it is the average distance of the sun from the earth, and it is about 1.496 into 10 to the power 11 meter. And second, these are the large units, these are the small units, these are large unit, practical unit that measure for different large distances. 1 light year. So, it is the light travel the distance in 1 year. So, is equal to 9.46 into 10 to the power 15 meter. Then 1 parsec. So, the parsec is the distance at which the average radius of the earth orbit subtend an angle of 1 arc second, and it is about 3.08 into 10 to the power 16 meter. 3.08 into 10 to the power 16 meter. Similarly, we can see range and order of length. So, size of object or distance, that is, and their length in meter. Size of a proton 10 to the power minus 15 meter. Size of atomic nucleus 10 to the power minus 14 meter. Size of a hydrogen atom 10 to the power minus 15 meter. Length of a typical virus 10 to the power minus 8 meter. Wavelength of light 10 to the power minus 7 meter. And size of a red bird red blood corpuscle 10 to the power minus 5 meter. Size of object is distance. Similarly, thickness of a paper 10 to the power minus 4 meter. Height of the Mount Everest above sea level 10 to the power 4 meter. Radius of the earth 10 to the power 7 meter. Distance of the moon from earth 10 to the power 8 meter. Distance of the sun from the earth 10 to the power 11 meter. And distance of Pluto from the sun is equal to 10 to the power 13 meter. So, size of our galaxy 10 to the power 21 meter. Size means its radius, diameter. So, distance to Andromeda galaxy 10 to the power 22. Distance to the boundary of observable universe 10 to the power 26 meter. So, MCQ question. Which of the following is not a unit of time? Microsecond, light year, leap year, lunar month, that is light year, because it is a unit of measurement of a distance. It is the distance travelled by light in 1 year. 1 Fermi equal to dash. So, 1 Fermi equal to 10 to the power minus 7 meter, 10 to the power minus 5 angstrom, 10 to the power minus 3 nanometer, none of the is. That means option B, that is 10 to the power minus 5 angstrom. Because 1 Fermi 10 to the power minus 5 15 meter and 1 angstrom is equal to 10 to the power minus 10 meter. When we divide it, it will be 10 to the power minus 5 divided by 10 to the power minus 10. When it go to denominator, it will be plus 10. Then it will be minus 15 plus 10 is equal to minus 5 angstrom. Then measurement of mass. So, mass is a basic property of matter. It does not depend on temperature or pressure or location of the object in space. So, आमे जानिछु the SI unit of mass is kilogram. The prototypes of International Bureau of Weights and Measures BIPM are available in many other laboratories of different countries. In India, this is available at National Physical Laboratory, New Delhi. So, kilogram and gram are inconvenient units for the measurement of mass of atom or molecules. In this case, we can use a unified atomic mass unit or 1U, because it is a very small mass. सेथिपाई आमर किलोग्राम बा ग्राम आमे यूज करि परिबा नाही टू मेजर द मास ऑफ इलेक्ट्रॉन, प्रोटॉन और एटम मॉलिक्यूल्स. So, it is used a small unit called atomic mass unit 1U or AMU. So, what is 1 AMU? Now, 1 AMU is the 1/12th of a mass of an carbon 12 atom or isotope of a carbon 612, including the mass of electrons. That is, it is about 1.66 into 10 to the power minus 27 kilometer. So, commonly mass can be measured with a common balance. Large masses in the universe like planets, stars, etc., based on Newton's law of gravitation and can be measured by using gravitational method. In mass spectrograph, radius of trajectory is proportional to mass of a charged particle in uniform electric and magnetic field. So, this is a physical balance. So, range and order of masses. The masses of the object we come across in the universe vary over a very wide range. So, electron mass order of 10 to the power minus 30 meter. Electron mass 10 to the power minus 30 kg, proton mass 10 to the power minus 27 kg, uranium atom mass 10 to the power minus 25 kg, red blood cell mass 10 to the power minus 13 kg, dust particle 10 to the power minus 9 kg and raindrop 10 to the power minus 6 kg. Mosquito 10 to the power minus 5 kg. These are the grapes 10 to the power minus 3 kg, human being 10 to the power 2, automobile 10 to the power 3, Boeing 747 aircraft 10 to the power 8 and moon is 10 to the power 23 kg. Earth 10 to the power 25 kg, Sun 10 to the power 30 kg, Milky Way galaxy 10 to the power 41 kg, observable universe 10 to the power 55 kg. So, which of the following unit of mass, that is kilogram, gram, all of the above? Atomic mass unit, kilogram, gram, all are the unit of mass. Mass of a substance can be measured with the help of spirometer, vernier capillary, screw gauge, common balance, that is common balance. Then measurement of time. Similarly, to measure any time interval, we need a clock. We now use an atomic standard of time, which is based on the periodic vibrations produced in a cesium atom. Cesium clock is also called as atomic clock, used in national standard. In the cesium atomic clock, the second is taken as the time needed for these vibrations of the radiation, corresponding to the transition between the two hyperfine levels of ground state of the cesium, that is 133 atom, cesium 133 atom. The cesium atomic clock are very accurate. In principle, they provide portable standard, the national standard of time interval. Second, as well as frequencies maintained through 4 cesium atomic clocks. Note that the Indian Standard Time IST is linked to this set of atomic clocks. The efficient cesium atomic clocks are so accurate that the uncertainty in time realization is plus or minus 1 into 10 to the power minus 13, that is 1 part in 10 to the power 13. But देखिए range of time, lifespan of a most unstable particle 10 to the power minus 4 second, time required for light to cross a nuclear distance 10 to the power minus 22, period of X-ray 10 to the power minus 19, period of atomic vibration 10 to the power minus 15 second, period of a light wave 10 to the power minus 15 meter, lifetime of an excited state of an atom 10 to the power minus 8 atom, second 10 to the power minus 8 second, period of a radio wave 10 to the power minus 6 second, period of a sound wave 10 to the power minus 13 second, wink of eye it is 10 to the power minus 1, time between successive human heartbeats 10 to the power 0, travel time for light from moon to earth 10 to the power 0, travel time for light from sun to earth 10 to the power 2 second, time period of a satellite 10 to the power 4 second, rotation period of the earth 10 to the power 5 second, rotation and revolution period of the moon 10 to the power 6 second, revolution period of the earth 10 to the power 7, travel time for light from nearest star 10 to the power 8, and average human lifespan 10 to the power 9 second, age of Egyptian pyramids 10 to the power 11 second, time since dinosaur become extinct 10 to the power 15 second, and the age of the universe 10 to the power 17 second. So, questions, which of the following is not a unit of time? So, parsec, lunar month, leap year, nanosecond. So, parsec is the unit of measurement of length. So, it is not a unit of a time. Which of the following is the most accurate clock for the measurement of a time? That is wall clock, wristwatch, pendulum clock and cesium atomic clock. So, correct option is cesium atomic clock. Thank you.